All right, picking up right where we left off with the previous video. The last thing we did was to write the electron configuration for neon. And I pointed out that the P6 slot on the periodic table is where the noble gases live. Now the other thing that I want to point out about this electron configuration is that these two spots that both have the 2s are what we call valence electrons. Okay, valence electrons are the outermost electrons in an element. Okay, and we're going to talk a little bit more as we go along about how to find how many valence electrons something has and what the electron configuration tells us about that stuff. So let's continue on. All right, so let's write the electron configurations for each atom and identify the valence. Okay, so go ahead and give us a pause. See if you can work this out yourself. You want a periodic table handy, and we'll pick it up in a second. Okay, so assuming that you did that on your own, let's check your work. So neon, we just did that one, so it's 1s2, 2s2, 2p6. Okay. And our sodium, let's take a look at a periodic table to find sodium. Sodium's living here at element 11. Right, so I'm going to list top to bottom, left to right, list everything as they fill. Remember the S's fill at 2, the P's fill at 6. So I start at hydrogen, that's 1s1, helium is 1s2. When I hit an s2, I list it. Now I go to row 2. Lithium's 2s1, beryllium's 2s2. So when I get to an s2, I list it. And then I continue along left to right. And we get to 2p1 with boron. And we go all the way over to 2p6. When I get to a p6, I list it. And then now I'm in row 3 and I'm at sodium is at 3s1. Right? So 1s2, 2s2, 2p6, 3s1. Right, so let's look at argon now. Right, so starting at hydrogen, say 1s1, 1s2, s2, I list it. Now row 2, beryllium is 2s2. Keep going across, and I go 2p1 all the way over to 2p6. When I get to a p6, I list it. Now I'm in row 3, and sodium's 3s1, magnesium's 3s2. When I get an s2, I list it. Then I continue straight across. Aluminum is at 3p1. P2, P3, P4, P5, and P6 is argon. 3p6. All right, so let's do our last one, which is potassium. Potassium sitting here at element 19. Okay, so I list everything that comes before it when it fills. So I say I've got 1s2 at helium, and then 2s2 at beryllium. It's right here. Continue across. 2p1, we end at 2p6 for neon. Now I'm in row 3. Magnesium's 3s2. Continue across. Aluminum is 3p1 all the way over to argon, which is 3p6. And finally we're in row 4 at potassium is 4s1. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, hopefully you got all of those, and if we take a look at our diagram on the right-hand side, let's note that our pattern of 1s, 2s, 2p, 3s, 3p, 4s, 1 all follows this same pattern. Okay, just reading left to right across the table, we accomplish our pattern. Now, our question was to identify the valence electrons. Okay, so in our electron configurations, pick the sets that have the highest numbers. Okay, so if I'm looking at neon, I have a 1s, a 2s, and a 2p. So I've got two of these that have a 2. Okay, and I'm looking for the highest number. So that 2s2, that 2p6, those are my valence electrons. So looking at sodium now. So I've got a 1s, 2s, 2p, 3s. So that highest number, and there may only be one set, that's my valence electrons. All right, let's look at argon. We've got a 1s, 2s, 2p, 3s, 3p. Those are my highest numbers. And I'm talking about the first number, the 3, the 2, the 1 in front of things. Okay, and then looking at potassium, 1s, 2s, 2p, 3s, 3p, and then I've got the highest number here is 4. Right? So neon, if I count all of those valence, there's 2 in the s, so we're talking about the 2s2 and the 2p6. There's 2 in the s and 6 in the p. That means that I've got 8 valence there. Right, looking at sodium, my highest set there is the 3s1. There's only 1 electron, so that's what the 1 means. So that means that I have 1 valence electron for sodium. Looking at argon, my highest set is the 3s2, 3p6. There's 2 electrons in the s, 6 in the p, so that means that my argon has 8 valence. And then my highest set in potassium is that 4s1, so that means that I've got 1 valence for potassium. Now notice that our noble gases, neon and argon, both have 8 valence. And that's actually part of what makes them noble gases, is that 8 valence. 8 is the magic number for atoms as far as electrons go. Right, so how many electrons are required to fill the valence level of most atoms? Remember what I was just saying, that the highest that I can get before I go on to the next level is 8. So 8 is the magic number to fill the valence shell. So what is the correct electron arrangement for phosphorus? Okay, so phosphorus, its electron configuration, 1s2, 2s2, 2p6, 3s2, 3p3. Okay, and remember what I said earlier in the previous video when we were doing this filling of electrons. We've got an arrow going up and an arrow going down. So, and then when we have our p orbitals, we want to fill those individually before we pair them. Okay, so looking at our first electron set, that top level, my p level, it's got 3 electrons in the p level just like my electron configuration does, but I've got one that's paired when it shouldn't be. Okay, so right away I can count that one out. And we look at B, and we should have 2, 4, 10, 12, 15 electrons total. Okay, and I can find that just by adding up the electrons in each shell. So there's 1s2, that's 2 electrons, 2s2, that's 2 electrons, 2p6, there's another 6, 3s2, there's 2 more. 3p3, there's 3 more. So when I add those up, I get 15. So if I'm looking at the electrons in my diagram above it, I've got 2, 2, 6, 2, 3. And that should add up to 15, which it does. And they're all individual before they get paired. Now let's look at our diagram C. We have 2, 2, 6, 2, 6. That's too many electrons. Okay, so C is out. That means B is our correct situation. Now, as you might have seen, when we start getting into larger atoms, the electron configurations start to get very, very long. Okay, so what we use is called the noble gas notation. Okay, and what we do is we find the noble gas just above, in the row above, and that tells us that piece of the electron configuration. So I can use a shorthand. So 1s2, 2s2, 2p6 is neon. That's the electron configuration for neon. So I can just list neon, and then all I have to put in there afterwards is everything that's in the same row as my element. Okay, so let's do a couple of those. All right, so the electron configuration for iron. All right, so let's find iron on the periodic table, and it's sitting here at element 26. So let's do this. So your task here is find the noble gas above your element. Okay, so right now iron is in row 4. So what's the noble gas in row 3? And that is argon. In the row above iron, my noble gas is argon. So I'm going to put argon in brackets, AR in brackets. So that tells me all of the information for argon. So that means that that's the shorthand for saying 1s2, 2s2, 3p6, 3s2, 3p6. Okay, so I don't have to say all that stuff in my list. So now all I have to do is list the things that are in the same row as iron. So I'm going to list left to right. So I have 4s1, 4s2 at calcium. So when I get to an s2, I list it. And then when I get to the Ds, remember the Ds drop down a number. So when I hit the Ds, now I'm at 3D. And iron is living at 3D6. Now remember what we said about valence. Okay, so valence is the highest number. Doesn't matter what order they're in, valence is the elements in the highest numbers. In which case, those are my valence electrons. Okay, not the Ds, just the stuff in the highest number. Okay, and these are my valence. All of this counts as my outer electrons. And what that's really meaning is that anything that is beyond the noble gas part, okay, counts as outer. My noble gas is what they're referring to as inner electrons. And then my highest number are the valence. All right, now we haven't talked about dealing with ions yet. So let's do that. So first let's do, the best way to do it is to start with neutral electron configuration. And I didn't spell that right, but that's okay. So start with the neutral electron configuration. So let's find selenium, and it's sitting over here at element 34. Okay, now I'm going to use the noble gas configuration because that's going to be a lot shorter than listing everything. So I'm going to look in the row above selenium and find the noble gas. That's argon. Okay, so we're going to say, I'm going to write it just below. So argon, and then I just have to list the things that are in the same row as selenium. So I'm in row 4, and so I say 4s2, and I list that, so 4s2, and then I read across, and when I get to the D's, remember I drop down a number, so 3D, and we go all the way over to 3D10. And then when I get back to the P's, I go back up to 4 again, and selenium is sitting at 4p4. Okay, so this is neutral. Okay, same number of electrons as protons. My 2 minus, that means that I have 2 more electrons. Okay, so the way that I deal with this is I add 2 electrons to my highest orbital. Okay, so I'm sort of running out of room here with this particular example, so I'm going to write down here at the bottom. So selenium 2 minus will have exactly the same electron configuration as regular selenium, but I add 2 more electrons to my highest level. Okay, so my 2 minus will say argon, 4s2, 3d10, 4p6. Okay? So now, I'm going to erase this business and look at the strontium 2+, our second question. Okay, so let's find the electron configuration for strontium. All right, so strontium is living down here at element 38. All right, now I'm going to look in the row above strontium and find the noble gas. That's krypton. All right, so I'm going to list krypton, and then I just list the stuff that's in the same row as strontium. And strontium's in row 5, column S2. So it's 5s2. Okay, pretty short electron configuration. So now a 2+, that means that I have 2 less electrons. Right, so remember, the electrons are negative, protons are positive, so if I have a positive charge, that means that I have more protons and less electrons. Okay, so all I have to do is take my electron configuration and subtract 2. Right, so my strontium 2+ will just be the electron configuration of krypton. Okay, or if it's asking for the full electron configuration, you can do that. So if I were to write the electron configuration for krypton, I would follow the same pattern as I normally do. I'm going to look at the noble gas above krypton, which is argon, and then list everything in krypton's row. So I have 4s2, 3d10, 4p6. Okay, so sometimes sapling will allow you to just write the noble gas part by itself, or it might ask you to write the electron configuration of that noble gas. Now let's take a look at something real quick. So our electron configuration for selenium 2-, remember it was argon, 4s2, 3d10, 4p6. It's the same as strontium 2+. Okay, so that's going to lead into our next topic on our next video.